In this video, we're going to complete example 4. We're going to convert the following network diagram into a precedence table. Now we'll start by looking at activity A, which is our edge here. Every edge will be attached to two vertices. So activity A is attached to a vertex at the left and a vertex at the right. Now, one of these vertices represents the start of the activity. So for activity A, the edge at the left represents the start of the activity. The vertex at the right represents the finish of activity A. Now, whenever you're trying to find the immediate predecessors of an activity, you need to look at the start vertex here. If we look at the start vertex, there are no other edges or activities connected here, meaning that activity A doesn't have any immediate predecessors. So we're going to put a dash here. That's activity A completed. Let's now look at activity B. Once again, activity B has a start and a finish vertex. So at the left, we've got the start, and at the right, we have the finish of activity B. As before, we look at the starting vertex to find any immediate predecessors. Now, when we look here, there are actually two edges, activities A and C, that connect to this same vertex. Now, do we write one of these down as the immediate predecessor, or do we write both of them down? It's important to note that an immediate predecessor will finish at the same point that your activity starts. So when we look at this vertex where activity B starts, you can see that activity A finishes here. So activity A is definitely an immediate predecessor for activity B. What about activity C? Well, we can see that activity C starts at this vertex and finishes at the vertex at right. So activity C cannot be an immediate predecessor for B because it doesn't finish at B's starting vertex. So we've completed what we need to do for activity B. Let's now look at activity C. Where does activity C start? It starts at this vertex here, and we're looking for an edge that also finishes at this point. And that would be edge A. So edge A or activity A is an immediate predecessor for activity C. Let's now look at activity D. Where does it start and finish? We can see that it starts at this vertex and finishes down here at this vertex. So we're going to focus on the vertex where activity D starts, and we're looking for any other activities that finish at this point. We can see that activity B finishes at this point, so we'll write this down to start with. But we've got two more edges to look at. We've got to look at edge F and edge E, which also connect to this vertex. Edge E starts and finishes like so, and edge F starts and finishes like so. So neither of these are an immediate predecessor because they don't finish at this point. So that's activity D completed. Looking now at activity E, we can see that activity E starts at this vertex here, and the only edge or activity that finishes at this point is activity B. So activity B must be an immediate predecessor for activity E. Let's now look at activity F, which is this activity here. We're going to look at the vertex where it starts, and there's only one edge that finishes at this point, edge B or activity B. Let's now look at activity G this time. So where does this activity start and finish? It starts at the left and finishes at the right. And when we look at this starting vertex, there are two edges that finish at this point. Edge C and edge D finish here. So these are the immediate predecessors for activity G. Let's now look at activity H. We can see activity H starts at the left and finishes at the right. So S and F for start and finish. And we can see that activity H's starting vertex has another edge that finishes at this point, edge E. So that's our immediate predecessor for activity H. Looking now at activity I, which we can see down here, it starts at the left and finishes at the right. Start and finish. And we can see when we look at the start vertex, there are two edges that finish at this point, edge F and edge G. F and G. And finally, looking at edge J, or activity J, it starts at the left and finishes at the right. And we can see when we look at the start vertex that there are two activities that finish at this point, activities H and I. And we have now completed our precedence table representing the network diagram at left. That concludes example 4. Remember to read the description below for links to workbooklets that relate to this video.